So I thought I'd explain how the cat game I'm making works. And so if I walk up here, you see things popped in. It knows I'm here. We're not going to discuss that right now, but that's important for later. And so the way these work, all these interactables, right? So they all use the... I have a class that is just an interface class. And this is it. It just says there's an interact thing, and it says there's an enable thing. That's useful for later. And the way it works, all of these other things, all these puzzle bits, all inherit from this interactable interface. It's not like an actual class, it's just an interface. All it does is say, these classes have these functions. We're not going to specify the details. We don't care about what variables there are. And the way it works is if I go into my player controller, which I should have had prepared beforehand, but it'll be fine. So if I go to my player controller, whenever I go to hit something, right? Or I'm trying to interact with something. So whenever I do interact, it checks, is the thing I'm interacting with an interactable? If so, go ahead and do the interact function. And then it says, all right, here's the interact function. And here's the interact on, say, the activator. So the way the movable works, right, if we go to its interact function, is it's very simple. It just has a set of coordinates, right? So here's that set of coordinates. Has some coordinates, it has some targets, and it just says move these targets according to these coordinates. We're going to cycle through them all and make sure that, oh, hold on, if I can zoom in, how do I do that? This is important. The lerp current position to location with the time passed divided by the transition time. So what that's basically saying is, as it sits there and updates, right? It has how much time has passed, which starts at 0, and as time passes, it gets divided by how long I want it to take, and it moves the position of the object towards the place I'm trying to send it as like a percentage of how much time has passed. So it'll slowly shift those as time.delta time ticks forward. And that's why in the how do I, oh my god, help. This was a curse. That's why in this, right? That's why they're shifting very smoothly instead of just teleporting across. Because they're shifting their position very slightly as time passes. And it's a similar story for the toggle, right? So the way the toggle works, I believe that's what the yellow do. No, the red do that. And these don't have, the reason they don't have to be the red ones toggle or whatever. I just have it set up that way so I can keep track of them. The color of them and the actual what they do are two separate things. We can get into that later. So if I go to the toggle, right, it works very similarly. I hit it, it wiggles, stuff toggles off. I hit it again, stuff toggles back on. But what's interesting is if I click on one of the things that is disappearing, right? So let me find it in the scene. This blue mushroom, for example, that's disappearing. Well, if I click on it and watch what happens to the collider specifically. So I click on it, watch here. The collider turns off. You notice something happened to the color of the sprite renderer, but the actual object is still enabled. And that's because what the toggle class is doing is it doesn't actually disable the object. Instead, what it does is it turns down the opacity of the object. Hold on, it's gonna drive me nuts. Whatever, I'll fix my zoom. Whatever. So what it's doing is it's turning off the opacity and it's turning off the collider, but the object itself stays active. And that's important for later, but it's not actually disabling it. That's the important part. And so what that means also is, for whatever reason, let's say puzzle-wise, if I wanted to do this, I don't know why I would. I could toggle them off, I could shift them, toggle them back on, and they're all still shifted. The objects still exist, and they're still, the other puzzle pieces can still interact with the ghost objects. They're still there. And the most complicated one by far was the color. So this is why it's a video instead of me typing. So the way the coloring works, if I click on one of my things, you'll notice, let me find the yellow ones. I believe those, yeah. So you notice the colorable script, right? All it has is targets. It doesn't tell it what color it should be. It doesn't tell it anything. It's just, here's a list of targets, color them. And the way that works is every single object that I want to assign colors to will go through. It has a script on it called the fluid color. And so what that does is it says, all right, here is my base color, which in this case is yellow. I can make it orange or whatever. And so what it's going to do is it's going to, damn, I need to stop clicking on stuff. It's going to take the targets and it's going to shift them towards the buttons color. It doesn't actually, that's why there's no assignable properties in the coloring script itself. It just shifts it towards whatever the color of the object itself is. And so the reason that these are enums instead of just a color value like you see up here in the sprite render, right? The reason that's the way it is that the so whenever you're doing puzzles, right? Originally it was just shifting the colors a little bit. But if you think about the way a computer handles color, and I can pull it up here, right? So the color is essentially just a vector of floating points. And so whenever the computer is trying to figure out, is this color the color that the puzzle needs? Well, if it's off by like 0.1, then the computer's not going to recognize that as a valid puzzle that's been solved. It's just going to keep saying, no, the player hasn't got the color right over and over again. And so instead what I have is I opted for some enums that have predefined colors that it'll shift towards instead. And so as the player interacts with it, it'll say, all right, what is the color of the thing? Well, what's the color of the puzzle thing being interacted with? And how will that react? Like, so you think of color charts. Hold on, let me. Or hold on, red. So you think of this, right? Everyone was taught this in school. It's the red, yellow, blue primary colors. So the way it works is it will shift. Say the mushroom, for example, right? It's yellow. So it'll shift it towards this orangey color. Same for, blue would be like green, whatever. And then if you get them across from each other, you get brown. And brown is like you failed the puzzle. So you need to reset it. And so what this is so the enum, instead of shifting the actual floating point values of the colors, it'll shift them one increment towards the middle ground between these primary colors, red, yellow, and blue. And I chose those because that's what you're taught in primary school. You're not taught red, green, blue, like the computer wants you to have. That's just a player intuition thing. So it'll shift the enum over by one value. So you notice, I don't know if I can zoom in on that, but the color red, whenever I hover over it, it says equals 0. That is an integer. You can shift enums according to what their integer value is. And so that's what I'm doing. Whenever the player interacts, it shifts the enum plus or minus 1 along this enum, or along the overall thing until it, you guys can't see me pointing at my screen. I'm pointing at my screen, you can't see it, whatever. And so that's the way it's shifting all these colors. And whenever it finds two colors like orange and blue that don't have a clear way to shift between each other, it just defaults to brown. And that's the way that works. So this makes it so that whenever the player is trying to solve all these color puzzles, there's set defined values. The computer can say, yes, this is in fact right. And the puzzles become much more easy to solve because you're not endlessly trying to get the exact perfect floating point. And I could have just put in tolerances for like if it's within this range of it, but that seemed more complicated and less fun, so I didn't bother doing that. I say as I've got this. Um, and so what's next? The interface also allows for, if I just want objects that just play their animation, the Interactable allows that. And also I have something called the Activator. And this is, it needs to be activatable. I need to change the color, the naming scheme, whatever. And so what this does is, that's what this, whenever it says player entered, right? If I leave and I come back here, things reset. This didn't, because I manually changed the this thing. It's not coded to deal with that. But the puzzle will reset, right? So if I do this and I walk away and I come back, things reset. And so that's how the player does this. And you can also just click on it. Oh, apparently you can't. That was working. I need to go through and troubleshoot that. I think that's just a I can figure that out, not too hard. Anyway, so that's how the player is resetting the puzzle. And it also means that as the player, say I get frustrated at this puzzle and I walk away, right? Then whenever I come back to solve this puzzle, because this might open up a new route or something, right? It'll just pop, you won't see the pop in, but it'll just, the puzzles, I don't need to worry about making sure the puzzle is set up correctly, because it's already handled. Whenever these things reset, it's handled. And the way that works is, so the reason the toggle only affects the opacity and the collider is that whenever objects are enabled and disabled, right? So on the fluid sprite, for example, or no. Hold on, I forgot my own damn script. I haven't worked with these in a hot second. I wrote this script like a week ago. Yeah, so the way it works, right, is it just it just sets all the locations and the colors back to how they should be. And that's more or less how this is set up. I forget. Yeah. Okay, so this is the fluid color itself. Notice it says on enable and not start. So every time it's turned on and off, the color resets to whatever the enum says it should be, right? Unless, and this is another thing I coded in, it doesn't have to follow the enum, like this tree, for example. If we go up to this tree, which looks really bad, we're not going to talk about that. Notably, this tree has a fluid color on it, but it's got an override, which means I can sit here and I can mess with the color values all I want, and they don't need to follow the enums, right? The game doesn't crash whenever I close out of this. And then whenever if I were to disable and enable this again, it's back to its default colors, which in this case is what the material wants, I think, or no, it's what I set in the inspector. So the thing will just sit there and reset. Or it should be. I don't know what the hell it's doing right now. I can fix that. I swear this works. Anyway, so that's why it the toggling only affects the opacity though. This is how I reset all the puzzles. And it's also why having the color thing, right? It only changes the enum, and the actual color is handled by the fluid color on the object itself. It's so that the toggle and the coloring shift don't fight each other, because if the opacity of an object is different than what the color shift is expecting, it'll crash it. So that's why the color shift only checks what the enum is set to. It doesn't actually check the color of the object. Probably could have explained this better. Yeah, that's more or less how my puzzling works. I've already done like 3 takes on this video, so this is the best you get. If you have any questions, I can answer them.